a 30 amp rated circuit breaker was installed for a range. The range's nameplate and paperwork indicated it required a 30 amp circuit breaker. However, the cord and plug were 4-wire and rated for 50 amps. This discrepancy can create a safety issue if the range is moved and plugged into a different outlet, as consumers may not always read the manuals. There are several possible explanations for this situation. Firstly, it is possible that the manufacturer or installer made a mistake by installing a 30 amp circuit breaker instead of the 50 amp breaker specified for the range's power requirements. Secondly, some ranges may be designed for European or international standards, which could allow for a lower amperage rating on the circuit breaker than what is typically used in North America. Thirdly, the range may have been installed before the electrical code required a 50 amp circuit for electric ranges. There are several safety concerns associated with using a circuit breaker rated below the amperage capacity of the range. One concern is the potential for electrical hazards. Using an undersized circuit breaker can cause it to trip prematurely or overheat, creating an electrical hazard. Another concern is the risk of fire. If the range draws more current than the circuit breaker can handle, the wires in the cord or within the circuit breaker itself can overheat and potentially start a fire. To address these concerns, several actions are recommended. One action is to upgrade the circuit breaker. It's essential to upgrade the circuit breaker to 50 amps to ensure the safe operation of the range. Consult a qualified electrician to perform this upgrade. Another recommended action is to replace the cord and plug. While the existing 50 amp rated cord and plug are appropriate, it's still advisable to replace them with new ones specifically designed for a 50 amp circuit. Another action is to clearly label the receptacle that the range plugs into as 50 amps. This labeling helps avoid confusion in the future. It's also crucial to promote consumer awareness. Educate consumers about the importance of using the correct circuit breaker and cord for their appliances. Manufacturers should provide clear instructions on the packaging and in the manuals regarding the electrical requirements of their appliances. Home inspectors and electricians should check the electrical systems of homes and alert owners to any potential safety issues. When dealing with electrical installations, always prioritize safety. If you are unsure about any aspect of the electrical work, consult with a qualified electrician. A qualified electrician will be able to assess the situation, determine the appropriate course of action, and perform the necessary work safely and correctly. They can also ensure that the electrical system meets all applicable codes and regulations. Electrical codes like the National Electrical Code, or NEC, provide guidelines for safe electrical installations. These codes are regularly updated to reflect the latest safety standards and best practices. When working on electrical systems, it's important to be familiar with and adhere to these codes. Some common electrical issues that homeowners may encounter include tripped circuit breakers, flickering lights, and faulty outlets. These issues can be caused by a variety of factors such as overloaded circuits, loose wiring connections, or defective component. If you experience any of these issues, it's important to have them addressed promptly by a qualified electrician. Ignoring electrical problems can lead to more serious hazards, such as electrical shocks, fires, and damage to appliances and equipment. Electrical safety is not just important for homeowners, but also for businesses and other organizations. Commercial and industrial electrical systems are often more complex and require specialized knowledge and expertise to maintain and repair. Businesses should have regular electrical inspections performed to identify potential safety hazards and ensure that their electrical systems are operating safely and efficiently. Electrical safety training is also important for employees who work with or around electrical equipment. Employees should be trained on how to identify electrical hazards, how to use electrical equipment safely, and what to do in the event of an electrical emergency. By taking these precautions, businesses can reduce the risk of electrical accidents and injuries. When working with electricity, it's important to follow these safety guidelines. Firstly, always turn off the power at the circuit breaker before working on any electrical equipment or wiring. Secondly, use insulated tools when working with electricity. Thirdly, never work on electrical equipment or wiring when you are wet or standing in water. Fourthly, inspect electrical cords and plugs for damage before using them. Fifthly, do not overload electrical circuits. Sixthly, use ground fault circuit interrupters, or GFCIs, in areas where there is a risk of water exposure, such as bathrooms and kitchens. Seventhly, have electrical work performed by a qualified electrician. Electricity can be dangerous if not handled properly. By following these safety guidelines, you can reduce the risk of electrical accidents and injuries. Always prioritize safety when working with electricity, and if you are unsure about anything, consult with a qualified electrician. The National Electrical Code provides specific requirements for circuit breaker sizing based on the type and size of the load being served. These requirements are designed to protect against overcurrents, which can cause overheating, damage to equipment, and even fires. When selecting a circuit breaker for a particular circuit, it's important to consider the continuous load in the circuit, as well as any intermittent or surge loads that may occur. The circuit breaker should be sized to handle the continuous load, with additional capacity to accommodate any intermittent or surge loads. For example, a circuit breaker serving a lighting circuit may need to be sized larger than the actual lighting load to account for the inrush current that occurs when the lights are first turned on. In addition to the National Electrical Code requirements, local electrical codes may also have specific requirements for circuit breaker sizing. It's important to check with the local authorities to ensure that the circuit breaker sizing meets all applicable codes. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current flow. These devices work by interrupting the flow of current when it exceeds a predetermined level. Circuit breakers are resettable devices that can be tripped and reset multiple times. Fuses are non-resettable devices that must be replaced after they have blown. Both circuit breakers and fuses are rated in amps, which indicates the amount of current that they can carry before tripping or blowing. When selecting an overcurrent protection device for a particular circuit, it's important to choose a device with an amperage rating that is appropriate for the circuit. A device with too low of an amperage rating will trip or blow prematurely, while a device with too high of an amperage rating will not provide adequate protection. The National Electrical Code provides specific requirements for overcurrent protection devices based on the type and size of the load being served. These requirements are designed to protect against overcurrents, which can cause overheating, damage to equipment, and even fires. Ground fault circuit interrupters are designed to protect against electrical shock caused by ground faults. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. GFCIs work by monitoring the current flowing through a circuit and quickly interrupting the flow of current if a ground fault is detected. GFCIs are required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor locations. They can be installed in outlets, circuit breakers, or portable units. When testing a GFCI, it's important to follow the manufacturer's instructions. Generally, GFCIs have a test button that can be pressed to simulate a ground fault. If the GFCI is working properly, it will trip and interrupt the flow of current. If the GFCI does not trip, it may be defective and should be replaced. Arc fault circuit interrupters are designed to protect against fires caused by arc faults. An arc fault is an unintended electrical discharge that can occur when there is a break or weakness in electrical insulation. ASIs work by monitoring the electrical current and detecting the unique characteristics of arc faults. When an arc fault is detected, the ASI quickly interrupts the flow of current, preventing a fire from starting. ASIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. They can be installed in circuit breakers or outlets. When testing an ASI, it's important to follow the manufacturer's instructions. Generally, ASIs have a test button that can be pressed to simulate an arc fault. If the ASI is working properly, it will trip and interrupt the flow of current. If the ASI does not trip, it may be defective and should be replaced. Electrical wiring is typically made of copper or aluminum. Copper is a better conductor of electricity than aluminum, but it is also more expensive. Aluminum wiring is often used in larger conductors, such as those used for service entrances and feeders. When installing electrical wiring, it's important to follow the National Electrical Code requirements for wire size, insulation type, and installation methods. The correct wire size must be selected based on the ampacity of the circuit and the length of the wire run. The insulation type must be appropriate for the environment in which the wire will be installed. And the installation methods must ensure that the wire is properly supported and protected from damage. Electrical panels, also known as breaker boxes, are the central distribution points for electricity in a building. They contain circuit breakers that protect individual circuits from overcurrents. The electrical panels should be properly labeled to indicate the circuits that they serve. It's important to keep electrical panels clean and free from obstructions. Never store flammable materials near electrical panels, and never tamper with electrical panels or circuit breakers unless you are a qualified electrician. The electrical outlets are the points where electrical devices are connected to the electrical system. Outlets should be properly installed and grounded. It's important to use the correct type of outlet for the device being connected. For example, appliances that draw a lot of current, such as refrigerators and air conditioners, should be connected to dedicated circuits with heavy-duty outlets. Electrical switches are used to control the flow of electricity to lights and other devices. Switches should be properly installed and wired. It's important to use the correct type of switch for the application. For example, dimmer switches are used to control the brightness of lights, while three-way switches are used to control lights from two different locations. Electrical grounding is the process of connecting electrical equipment and wiring to the earth. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock and equipment damage. All electrical equipment and wiring should be properly grounded in accordance with the National Electrical Code. Electrical bonding is the process of connecting different metal parts of an electrical system together. Bonding ensures that all metal parts are at the same electrical potential, which helps to prevent electrical shock. All metal parts of an electrical system should be properly bonded in accordance with the National Electrical Code. When working with electricity, it's important to be aware of the potential hazards and to take precautions to protect yourself and others. Always turn off the power at the circuit breaker before working on any electrical equipment or wiring. Use insulated tools when working with electricity. Never work on electrical equipment or wiring when you are wet or standing in water. Inspect electrical cords and plugs for damage before using them. Do not overload electrical circuits. Use ground fault circuit interrupters in areas where there is a risk of water exposure. Have electrical work performed by a qualified electrician. The information provided in this narration is for general informational purposes only and does not constitute professional electrical advice. Always consult with a qualified electrician for any electrical work or concerns. Electrical codes and regulations vary by location, so it's important to check with the local authorities to ensure that all electrical work meets the applicable codes. Remember that electrical safety is paramount, and it's always best to err on the side of caution when working with electricity.